Alright, so we're going to go over the check understandings for 12.1. And we're going to go to explaining what this computer table really plays out to be and how that is read. That's very important. It's really nice when they give you this table because it gives you a lot of information. So with this, I'm not going to read through the problem here. It's not really necessary for this setup altogether. It's mainly understanding how to read through this table. But you can read through that problem if you'd like. So with this, for the setup here, when we're dealing with this, we're looking at this equation for least squares regression line, right? So we're looking right here. So we have your y hat equals your b sub 0 plus your b sub 1 times x. In other words, your b sub 0 is your y-intercept, and your b sub 1 is your slope, okay? In which case, we'll talk about that. As mentioned right up here. All right, so your b sub 1 is your slope, and your b sub 0 is your y-intercept. So again, we write it out like this. In a statistic way down here, what we just talked about, actual way to write out with your lowercase b as well, your b sub 0 plus your b sub 1 times x. So when you have that type of equation, now we need to figure out what these values are by looking at the table that's given to you in the problem. So with this, when you're given this setup, your predictor, coefficient, standard error, coefficient, T and P, we're not going to worry so much about the T and P. So don't worry about these values too much on the T and P. The main thing we're going to look at for the coefficient and standard error coefficient as well, these values are what we're going to play into, okay? As well as your S value here. So as you can see, that should take everything because S is your standard deviation of residuals. So that's another key one to make note of, standard deviation of residuals. So we'll talk about that. As well as your SE value, which we'll talk about in a second. So first off, to find this is what is the estimate for your b sub 0? Well, your b sub 0 is your y-intercept, and that's always going to be this first number right here, your constant value under the coefficient column, okay? So this right here is going to be your y-intercept. And if your y-intercept, so your b sub 0, same thing as your y-intercept. Therefore, this value is negative 0.03761. That is how this table is always going to be set up, and it's always going to be that value as your y-intercept. Now, if you're looking for your b sub 1, well, that's going to be your slope, right? And your slope is always going to be, this value right here underneath your y-intercept value. In this case, they're talking about drop height. They just want to know how these helicopters, I believe, dropped from the drop height. So that's your slope for the value. I'm going to write that over here. See if I can write that in here. Slope. Okay. So for your slope value, you have 0.0057244. So your slope value is always going to be that second number listed under the coefficient set up for it, in which case it would be actually dealing with the context of the problem, whatever it's talking about. In this case, it's talking about drop height. Okay. For the next one, it's saying, what is the estimate for the standard deviation? Well, for the standard deviation, in this case, what we talked about over here, standard deviation of residuals is your S value right here. Okay, so it's your S value. So we're looking at our S value. That's this guy right there. So for this, the standard deviation, which is your S, is going to equal your 0.168181. Okay, and that's telling you the actual flight times typically vary by that value of 0.168181. seconds from the times predicted by the least squares regression line. The last one there I just want to know is saying given the standard error of the slope. So we want to give that standard error of the slope, and that's also given to us in this problem as well, this table up here. So with that, your standard error of the slope, your SE subscript B1, it's right here, okay, your standard error slope. That value is always going to be under the standard error of the coefficient right here for the context right here. So this value right there, always going to be that value right there. So this is standard error of your slope, okay? So let's scroll down a little bit here. So the standard error of the slope is going to equal 0.000218, okay? And that's saying, for interpreting this, if we repeated the random assignment many times, the slope of the sample of the least squares regression line typically varies by 0.00218 from the true slope. And that's what it's talking about for those. So this first part of the check your understanding is just make sure you understand how to read this table off of this computer generated data for the least squares regression analysis, okay? So again, your y-intercept is under your coefficient, the top part there with your constant. Your slope is right underneath that if we're dealing with the context of the problem, for in this case the drop height under the coefficient value. Then you have your standard deviation is talking about your S value in the green, and then your standard error of the slope is listed on the standard error coefficient for the context of the problem. In this case is the drop height, so that's in red, in which case those values will always be in that order. Of course, the numbers will be different depending on the problem, but that is how it's always going to be laid out every time, okay? All right, so let's go on to the next part of this. So in this one, you got a nice little problem there. I'll let y'all read through that. We'll go on to talk about this. So we're going to be doing our state plan, do and conclude with this. And therefore, the big ideas that I've given you guys are right here. And the things you need to worry about a little bit different here as far as a state, as far as dealing with your B sub 1, the true slope of the population least squares regression line, and the statistic sample slope, okay? And we'll also talk about our confidence levels. So let's give those values because we have all that and what we're talking about. So in other words, this top part with a capital B, right, subscript 1, talking about the true slope of the population. So in other words, what's talking about the context of the problem, you're listing that out. This lowercase b subscript 1 is statistic, which is going to be given to you in that table there somehow. You got to know where to find it though, right? So we should be able to find that no problem. And then the confidence level. Again, they'll either give that to you, or if they don't, it's understood to be a 95% confidence interval for the most part. But I imagine they will actually give you the confidence interval, so therefore it's not too confusing. The other thing we're going to talk about too, we'll go into this, of course, is dealing with your formulas. We'll talk about how this plays out with the formulas we get to it. And degrees of freedom change a little bit. Instead of subtracting 1, we'll subtract 2 from the sample size. And the conditions. The conditions are a little bit different because we're going to do, we like to use the acronym linear here. And if we can explain all these out in the conditions, then we're all good. So let's look at this problem. So let's start out with this. We were talking about dealing with the state. So we need to state this information out. So for state part, in which case we want to talk about big B subscript 1. And this is saying that with reading through this problem, it's talking about the slope of the population of the least squares regression line for price Y and miles driven, okay? So again, that's the slope of the population least squares regression line for the price, in this case Y, and the miles driven, which is represented by your X, okay? So now our our lowercase b subscript 1, in other words, our slope, right? When we talked about this, our slope is always this value right here. And our coefficient, and then our context, which gets miles driven. So our slope value is negative 0.16292. And the last thing we need to deal with our state part is our confidence interval. In which case we're talking about, even though it's given to us, we'll say it's 95% confident. Oh no, I'm sorry, I think it said 90% confident. 90%. Okay. Now, scroll down a little bit. Next part, after dealing with our state part, we can deal with our plan. So let's deal with plan. So again, I said plan is using that linear setup, right? A little acronym there. So for our plan, in this case, we can talk about our L, which is linear. Okay, actual word linear. So we'll talk about that, in which case, we're looking at our scatter plot up here. May have talked about this being way back in the day in the beginning of the class. We were looking at these, and we looked at this, so we have a linear line, right? So the scatter plot shows a linear pattern. Okay. As well as we understand that it's going to be linear, it's going to work well, because if we look at our residuals, because residuals are all scattered, right? There's no form according to the residuals, then it's a good fit for it because it's scattered plots on the residuals. So therefore, the linear line for this data works out. So again, with linear, scatter plot shows a linear pattern. It's a decreasing or negative linear pattern, right? And the residuals show no leftover pattern. Okay. So now we could talk about our I, in which case we're talking about independent. So we're seeing it as dependent. Well, in this case up here, we had, I believe there was 16 trucks. Yeah, we had 16 used Fords, okay? So we have 16 used Fords, so we're gonna say that 16, of course, is gonna be less than 10% of all F-150s. Okay, so that's definitely an easy assumption to make. So now we're going to look at our N for normal, in which case we saw no strong skew or outliers in the residuals, right? There's no strong skew in this setup for it. There's no outliers. So we can see, according to looking at our data plot there's no real apparent outliers, as well as even in the histogram they made here. And there is no strong skew. It looks like a pretty symmetrical setup there, unimodal. So with that is all we're going to say. No strong skew or outliers. So again, no strong skew or outliers listed for being the normal. Now we can deal with saying for our E, for equal standard deviation. And to look at that, we're going to look at our scatter residuals around 0, right? So we're going to look up here on our residuals and this middle scatter plot here. So again, 0 is that blue line right in the middle, and we're looking to see if it's fairly equal setup for the standard deviation from that, in which case, because they're all scattered, therefore it is good, right? It's about the same for all the x's. Okay, so that's all we're going to say is scatter plot residuals around 0 is about the same. So the scatter residuals around 0 is about the same for all x's. And the last thing we're going to talk about is your R. In which case, we're talking about saying random. And they told us up there that there was a random sample of 16. So we're just going to say random sample of 16. And you can say the context trucks, right? Or F-150s, however you'd like to word that. A random sample of 16. Okay, so the next part we got to do is the do part, in which case that was the formula set up here is what we're really going to play into dealing with this for the do part. So dealing with those guys right in there. The color for this one, we'll say, make it purple. So we're going to say for the formulas dealing with the do part, we're going to say these equations right here, we're going to use these equations, okay? So for this, the do part. So we have our point estimate plus or minus our margin of error. Okay, well, our point estimate is simply going to be the B1, right? It's given to us in our big idea as far as that plays out, the B1 value, B subscript 1. Then we say plus or minus, in this case, our T star value, which we'll calculate that here in a second. And then dealing with our margin of error, T star times your standard error will give you your margin of error, okay? So now, first off, before we get moving with this, let's find our T star. So if you have a TI Inspire, I'll show you how to do that real quick. So with this one, you would simply say, the menu, statistics, and distributions, and we're going to do inverse T, our area. Now we're doing 90% confidence interval. So you would take 1 minus 0.9, which gives you 0.1, and divide that by 2. So we should have 0.05 for our area. And so for the degrees freedom, it's a little bit different, in which case we got to look at dealing here with your degrees freedom. It's going to be your sample size minus 2. Okay, so our sample size minus 2, we said our sample size was 16, I'm sorry. 16, and then so we're going to take minus 2 would give us 14. Okay, so we should get 1.76131 for our T star, in which case we'll just use 1.761. So back to our problem here. With this, scroll so we see our other values here. Again, we know what our B1 value is. We set it right in the middle, the beginning of our state part, right? Our B1 is negative 0.16292. We're going to say plus or minus our T star value, which we said was going to be on our calculator, we said was 1.761. 1.761. Now, again, if you don't have a calculator to calculate that, we can use our tables. Okay, so for our T star value, if you don't have a calculator, you can use table B, which I've uploaded on Canvas for you. Okay, so your T distribution values. Well, with this one, you're going to look at your degrees freedom over here. Okay, degrees freedom, and we said it was 14. We took 16 minus 2, so we're looking on this row. Now, we also said our area was dealing with 0.05. So we're looking on this column. So these meet right here at this value. So what we got on the calculator is exactly what you got on the table. Because the table says 1.761. So therefore, that is why easiest thing to use is that value right there. Okay. Whether to the calculator or on the table, you can figure out your T star value. Then our standard error of our slope, again, we said was this value right here. That's your standard error. Okay, so that's given to you in the table as well. So we're looking at that value is 0.03096. Okay. So we do some calculations to get that figured out, and we should come up with getting plus and minus values of those. We should get a negative 0.21744 is what I got for my lower setup on my interval. And for the upper part of my interval, I got negative 0.10840. Okay. So then we just go on to our conclusion. So our conclusion. Okay. So we're going to do our state plane to conclude. And our conclusion is that we are 9% confident that the interval from negative 0.21744 to negative 0.10840 captures the captures the slope of the population least squares regression line for the price and miles. All right, so again, we are 9% confident that the interval from negative 0.21744 to negative 0.10840 captures the slope of the population least squares regression line for price and miles of dealing with these Ford F-150s. Okay, so with that, again, big ideas from the part one is understanding on how these lay out, definitely in these computer generated tables for the ability to write out your least squares regression line formula. Okay, understanding what these values are, dealing with the S for this standard deviation residuals, and then your standard error of the slope being the SEB1 is found in that other part, is found right there in the purple on this value right there, next to the standard error coefficient for the context of the problem. In this case, on this problem, it was miles driven. All right, so make sure those are at, as well as there's a write-out of how to interpret these down there as well. And on the next part is actually understanding that for the state plane to conclude, understanding the state, what you need to list out in your state part. So having all three of those guys, all right? Your formulas are key, understanding how to write that out as well, what your point estimate is, how to calculate your t-star, because in this case, dealing with your sample size minus 2. Oh, and I forgot one thing. And y'all probably caught me on this. I didn't label what test I was doing, right? I did my plan part. I didn't say one sample t interval for your b subscript 1. That was your slope. So here, in my plan part, I got too wrapped up in talking about the acronym there. So again, we need to also label here, it's a 1 sample t interval for the slope, right? Your b subscript 1, okay? So with that, so understanding the name of that as well as the formula to use for the setup and the confidence intervals, and the conditions are key as well. Conditions are very important. So it's totally different than what we dealt with altogether. So those conditions are very important to get notated down for linear, independent, normal, equal standard deviation, and random. All right, so hopefully that helps explain a little bit on the check understanding for 12.1, and I'll see you next time.